You don't think it needs any changing?
No, the website, it works well if you don't download it also.
Okay, good. It's good to know. Yeah. All right. This is what we're looking at today, starting with question 6.
Yeah.
All right. What kind of calculator do you use?
A TI-83.
Okay. I assume they want you to answer this question without doing the linear regression.
I don't know.
Do you know, have you heard that expression before, linear regression?
I don't think so.
Okay, then I assume they don't want you to do this by calculator. Let's look at number 6.
Okay.
If you had to draw a straight line through those data points, it would look something like that, correct?
Mm-hmm.
Or perhaps I didn't draw it quite accurately. Might look like that. Might look like, let's see, let me see if there's any other. Yeah, I could increase the slope a little bit, draw it like that. So any of those 3 lines might be the best line to represent those data points. But clearly, some form of a straight line with a negative slope is the best way to represent them. In other words, those data points do suggest that the further you go to the right on the x-axis, the further you go down on the y-axis. Would you agree?
Yeah.
That's a positive correlation. Well, that's a negative correlation. In other words, there is a correlation, but it's negative because the slope is negative.
Okay.
Okay? Now, let's look at number 7. If I were to do the same thing on 7, I might draw a line like that. Or maybe it would deviate a little bit from that. Maybe it would be more like that. And if I wanted a third possibility, that could be it. Okay?
Would that be a positive correlation?
I'm sorry, what?
Would that be a positive correlation?
That is a positive correlation. Clearly, as the x values increase, the y values increase. Okay? Now, your calculator, if you were to put all of these data points into a couple of lists, your calculator has an algorithm for determining which of these lines is going to be the best fit.
So when you hit like stat on your calculator and then do all the numbers.
Yeah, exactly. You want the linear regression.
Okay.
Okay? And what it's going to give you is in terms of our standard slope-intercept format. It's going to tell you what M is, and it's going to tell you what B is. Say in the first case, it might tell you M is minus 1.1. The second, and the B-intercept in the first case might be minus a half. Okay? So if you were to put these points into your calculator and ask it to do a linear regression, and then it's going to give you an R. And the R, in this case, might be 0.7. It's a pretty good fit. R is anywhere from 0 to 1. Now, I'm getting a little ahead of probably what you're learning right now, but
Actually, we did learn that. We did learn that. I didn't know that we did. That's what you're talking about, though.
You did not learn this?
No, we did.
Oh, you did? Okay, well, good. Let's talk about it then. In other
Okay.
words, if I had a series of points like this, and I draw the line through it, that has a bigger r. This r might be 0.9. If every point was on the line, r would be 1. So r goes from 0 to 1. And it's basically a measurement of how good a straight line fits these data points. And basically what they're measuring is the distance from the line. In other words, that data point is that distance from the blue line. That data point is that vertical distance from the blue line. They sum up all those differences and they minimize it. So they come up with the perfect line that fits a linear regression on these points. And the measurement of that fit is r.
Okay.
In the example I've drawn, it's a very high fit. In other words, almost every point is on the line. So r would be very close to 1. I'm guessing 0.9. And r that would be 1 would be points like this, where the line goes through every data point. In other
Okay.
words, this would say there's no scatter at all. If you can draw a line through every data point, you get a perfectly straight line. That's an R of 1. Okay. This one, there's a little bit of scatter. So that's an R of 0.9. On this one here, there's some scatter. In other words, there's significant distances from there to there, and there to there, and there to there, depending on which line we pick. So when you have some scatter, the more scatter you have, the less R is. Okay? And the scatter on this one is about the same as the scatter on that one. So I would guess the R's would be pretty equivalent. If I had to estimate R, I would say R there is also about 0.7. It's not negative 0.7. It's R is strictly a measure of how well the data points fit the line that you end up putting through there. And none of us really know how to do this manually, but that's why you have a graphing calculator, because it allows you to put in a couple of lists of data points and it will come up what the equation of the line is that is the best fit. And that's exactly what it's called, a best fit linear regression.
Okay.
Okay, now let's look at the third. Hold on. Can I draw a line through that?
No, I don't think so.
Well, I do see 4 points here. I probably could draw a line through that. But the scatter, in other words, if I were to sum up all of these vertical distances from every point to the line, the scatter is pretty big.
Mm-hmm.
And I would guess that might have an R of 0.1. In other words, I'm not sure I can really draw a straight line that represents all those points. My straight line could also be maybe that or that. They all have about the same scatter. So this, I would be inclined to say, has a relatively no correlation.
Okay.
We're really kind of talking about statistics here, and statistics is not pure math. It is a little bit subjective. Okay? In other words, we might relatively. That's not a mathematical term. Relatively means approximately no correlation. It could have a little bit of correlation. I did find a line that I'll bet that would be the least. If you put these points into your calculator, I bet it would give you something like that. But that would be a very low R. So I would say that this has no correlation.
Okay.
Okay. Now let's look at the last two. Let's simplify that inequality first of all.
Okay.
Number 9. What's that simplify to? Solve for y.
Would that be 3?
Y is less than or equal to 3. Okay. Now, in order to graph the inequality, you kind of have to think of it as an equation. How do you graph y equals 3?
To 0 and then the 3 on the y, right?
What kind of a line is it? Is it a line with slope? Is it a horizontal line or is it a vertical line?
Vertical.
No, horizontal. In other words, and the reason it's horizontal, if you think about it, is because what it's saying is that no matter what x is, y is 3. That's what that says. X could be 0, y is 3. X could be 5, y is 3. X could be infinity, y is 3. Okay? So that's why all horizontal lines are y equals some number. All vertical lines are x equals some number. With me? Okay. So I know the equation would be a straight line. But we're dealing with an inequality, and inequalities can be either solid lines or dotted lines. And it depends on what that is. If that is a less than or equal or even a greater than or equal, then it's a solid line. If it's a less than, it's a dotted line. If it's a greater than, it's a dotted line. So this is less than or equal, so it's definitely a dotted line. Now I got to figure out which side to shade. And when they say graph an inequality, that's always part of it. You're not graphing it unless you indicate which side is in the solution set. Well, which is it? Is it above or below?
Above?
Look at what I have circled. Y is less than or equal to 3. So,
okay, so then it'd be below.
Yeah, whenever you're trying to figure out which side to shade, you need to look to the y-axis only. Do not look at it horizontally. This is a bit of a trick in math. When you're looking at graphs in the xy coordinate plane, you have to train yourself when you're examining things like domain, you're looking horizontally. When you're examining range, you're looking vertically. When you are looking at inequalities, almost always the answer is above or below. And the only thing you need to do is look at this. That's y is less than. So I look strictly to the y-axis. I find a point that's below. There's a point that's below. That tells me which side to shade. In other words, I'm going to shade this side here. And the solution set is all of that. Okay?
Okay.
Okay. Now, let's look at 10. Now, first of all, we got to graph that. And the best way to graph it is to put it into y equal mx plus b format. Y equal mx plus b. Everybody pretty much knows how to graph it if it's in that format. Okay? So remember, let's treat this as an equation first. And then we'll switch back and treat it as an inequality. Hold on 1 second. All right. So solve that equation for y.
Would you divide by 2? Why?
Well, your final thing has to be y equals. So you've got to get rid of everything that's not y. What's the first thing that's not y that's being added?
X.
Okay, let's get rid of that. How do I get rid of that?
Subtract it.
Okay, so that gives me minus x plus 2. And that's 2y. Okay, so that's the next step of the equation, right?
Mm-hmm.
Now what? We still have an isolated y. We still got to get rid of the 2 that's in front of the y.
Divide it.
Okay, so that's y equals what?
1.
You're dividing both sides by 2. That's what you're doing. That's going to get rid of that. Okay, so the left side is y. That's what we're trying to accomplish. What's the right side? Remember, we're trying to get it into this format, y equal mx plus b. That's not quite y equal mx plus b. It's close, but I can't graph it from that. I got to get it into the exact format, y equals mx plus b. So I need that to be separated into 2 fractions. What are the 2 fractions? What is y equal to? Here's what we have. We have minus x plus 2 over 2. So the way you separate that into 2 fractions is this way. That's 1 fraction. That's another fraction. So what's the first fraction?
So would it be 2x?
No, look what I've circled there. What's it look like?
Negative x.
X over 2, right?
Yeah.
Okay, that's what the answer is. Plus what? What's the second fraction?
1.
Okay, good. Now, there's actually a better way of writing this. This is not exactly an mx plus b format yet. What's the way to write that so I know exactly what the slope is? Can you tell me what the slope of that is, of that line? Do you know what m is?
2? Negative 2?
No. That's why you need to write it in a better format. You see where that is the same as that?
Oh, yeah, that makes sense. Okay.
And it's very important you understand that those two are the same. A lot of people have problems with that. When you are dividing the variable by a whole number, people have a lot of difficulty turning that into minus 1/2. But that's what it is. Those two things are the same thing. Now tell me what the slope is.
Negative 1/2.
And what's the y-intercept?
1.
Good. So negative 1/2 and 1. We're going to start where?
At the 1.
Okay, here's actually what our equation is. In other words, I've turned it back into an inequality because you'll see why. Okay, that was our equation, correct? Now, to graph it, we know it's a straight line. Is it a solid line or a dotted line?
The dotted line.
Okay, good. Where do I begin in an attempt to graph it?
You would start at the 1.
Okay, so that point's on the line. Now where do I get another point? Is all I need is one other point, and I know 2 points to determine a line. So
And then would you go down 1 and then left 2?
that would give you a positive slope, would it not? If I did
Well, yeah.
that, and I can see this is a negative slope. And that's the way to think about it. I don't care if you go up and over, up and right, up and left, or down and over, down or right, down or left, as long as you end up with the right slope. You have to know your slopes. You have to know what's a positive slope and what's a negative slope.
Okay.
So you were close. I want to go down 1, but which way do I need to go, right or left?
Right.
Okay, so there's another point on the graph right there. And now I can draw a straight line through those 2 points, straight as I can draw. And we can figure out, whoops, that was supposed to be a dotted line. Go back and draw a dotted line. All right. So that fits everything except we need to figure out which side to shade.
Okay.
Remember, look to the y-axis always. The answer is always above or below. It is once in a blue moon left or right, and I'll cover that as soon as we're done with this problem. But usually it's above or below. As long as you have a y right there, then the y-axis is the only thing you want to look to. Well, what does y have to be relative to this dotted line?
What do you mean?
What's it say?
That it's greater?
Uh-huh. So what's that tell you?
It has to be above the line?
Exactly. I pick any point on the y-axis that's greater. Well, that point would be, that point would be, that point would be, that point would be. All of them are above the line. And that tells me that's the side I have to shade.
Okay.
Okay? Now, there's only one exception to that. And I'm going to go over here, and I'm going to give you a real quick one. X is greater than or equal to 2. If I have a vertical line, which is what that is, now there's no above or below that line. There's only right or left. Which side am I?
Right?
Yeah, because X is greater than that line. So I would shade that line. But that is the only time your answer is ever right or left. In
Okay.
other words, if I had a line like this, let's call that line y is greater than or equal to 100x. That's it. Which side of that would I shade?
The right side still?
Remember, the answer is never left or right. The answer is always above or below. You have
The
to think
below.
about it like that. Even though it's very tempting to think about this as left or right, you don't want to do that. You want to look to the y-axis only. This is the key part right there. Y is greater than that. So find a point on the y-axis that is above this point right here where it crosses the y-axis. So where does that put it?
So like 2 and then like 2, 3.
Well, all of these points are above
Yeah.
that, right?
Yeah.
So which side am I shading? Above or
Uh,
below?
above.
Huh. Above is that side right there. And I purposefully avoided saying left or right because that is not the way you want to think about it. You are always thinking about it in terms of the y-axis unless you have an equation or an inequality that doesn't have a y in it. In other words, when I have that, there's no y in that. That answer is going to be left or right, but that's the only time. If there is a y in it, and it's on the left side of the inequality entirely by itself, then your answer is always above or below.
Okay.
Okay? That take care of you for today, Haley?
Yeah, that helped me a lot.
Okay, cool. I will let you go and you have a good weekend.
You too.
All right, bye-bye.
Bye.